Hello, this is question 4 on your AQA AS paper from November 2021. So ABC is a trapezium where A is the point 1 minus 2, B is the point 7,1, and C is the point 3,4. DC is parallel to AB and AD is perpendicular to AB. So this is something like, so one is perpendicular to one of the sides. Then we have something like this. So AB and DC are parallel. So this would be AB, for example. And AD is perpendicular. So this one and this one. And we know the coordinates of A, which is 1 minus 2, and B, 7, 1, C, 3, 4. We don't need to draw it. It's just, I think it helps. Find the equation of the line CD. CD is this line. It's parallel to this one. So we don't know this point, but we know one point, and we know the gradient because it will be the same gradient that AB. So let's go to do that. Gradient of DC, which is the gradient of AB, is going to be difference in y. So 1 minus minus 2 is 3, divided by difference in x, 7 minus 1, 6. So the gradient is 1/2. So if we use that y minus the y of the point is gradient brackets x minus the x of the point, we have that y minus y of the point, and this is the point of the line, so y minus 4 is going to be gradient 1/2 x minus the x of the point, which is 3. We can leave it like this, or we can just multiply by 2 and reorganize a bit. So 2y minus 8 is x minus 3. Therefore, 2y is going to be x plus 5, no? And this would be the equation of line DC. So this is line DC. That's the first part. Then, show that point D has coordinates minus 1, 2. Point D is the only missing point. We can find this point doing the intersection of this line, which is this one, with this line, which we don't know it, but it's very easy to find because we know the gradient as being perpendicular to this line is going to be negative reciprocal of this one, and we know one point. Yeah, so we can write the equation of the line AD very easily. So line AD, the gradient of AD is going to be negative reciprocal of DC, so it's going to be minus 2. And the line is going to be y minus the y of the point. We are going to use this point, so minus minus 2 plus 2. Gradient brackets x minus the x of the point. Expanding the brackets, I have minus 2x plus 2. We can cancel the 2's, and we have y is minus 2x. If I do the intersection with this line, so line DC with line AD, so DC with AD, with DC, sorry, AD with DC, we will get point D, yeah? So we are going to do the intersection between those two lines. The y equals minus 2x, and 2y equals x minus 5. Remember, every time we find intersection, we just solve simultaneous equations. So I can, for example, substitute this y here, and I have 2 times minus 2x is x plus 5, which means minus 4x is x plus 5, which means 5x is minus 5. Therefore, x is minus 1. And once we have x, we know that y is minus 2 times x. So y is going to be 2. Yeah, and that's the point minus 1, 2 that they asked. Yeah, this is the next part. Then find the sum of the length of AB and the length of CD in simplified short form. AB. Length of AB is going to be the square root of difference in x squared. So AB, difference in x squared, is 7 minus 1, 6 squared, plus difference in y squared. So 1 minus minus 2 is 3 squared. This is 36 plus 9, which is 45. 45 is 9 times 5, we can get the 9 outside as 3 because it's root 9, root 5. Yeah, that's the first one. And then the other one is CD. CD is square root of, we know D now is minus 1, 2. So CD is going to be difference in x, so 3 minus minus 1 is 4, so 4 squared, plus difference in y, 4 minus 2, 2, 2 squared. So we have 16 plus 4, which is 20. And if we simplify, you can do, when you write root 45 in the calculator, you're going to get the root 5 anyway. Is root 5 times 4. It's just to remind you, because sometimes you have to do this with letters, and then you cannot use the calculator, yeah? And they asked me the sum. So AB plus CD is 3 root 5 plus 2 root 5 is 5 root 5. Yeah, that's the sum. And the last part says, hence, find the area of the trapezium. Remember the formula of the area of the trapezium is sum of the parallel sides divided by 2 and then multiplied by the distance between them. The sum of the sides is precisely what we just found. Yeah, it's this 5 root 5 divided by 2. And we need to find this distance. Yeah, so AD. And we are going to do it in a very similar way. So we are going to find AD first. AD is square root of difference in x is 1 minus minus 1 is 2, so 2 squared, plus difference in y is minus 2 minus 2 minus 4, so 4 squared. 2 squared plus 4 squared is, as we had before, 2 root 5, which means the area of the trapezium is going to be sum of the parallel sides divided by 2 and then multiply by the distance between them. So we can cancel these 2 with these 2, and then we have 5 root 5 multiplied by root 5, and root 5 becomes 5 times 5, 25. Yeah, and that's the area. We don't have units. Yeah, it's just coordinates, so the area just 25. Yeah, and that's all with this question.